Have you ever felt like your brain just wasn't built for learning a new language? I think we've all been there. Well, it turns out that whole frustrating, mistake-filled process, it's not just normal, it's actually predictable. So today, we're going to dig into how a computer model that learns just like a human is revealing the hidden patterns behind how we really master language. I mean, it's the big question, right? Why is it so incredibly difficult? Is it really just about memorizing endless vocabulary lists and grammar rules? Or is there something much deeper, something a lot more complex and intuitive going on inside our heads? So here's our game plan. We'll start with the core challenges of learning a new language. Then we'll get into the big theories of how we learn in the first place. After that, we'll meet the machine they built to test those theories. We'll track its very human-like learning curve. And finally, we'll see what its journey reveals about our own brains. All right, let's dive right in. The second language challenge. Because mastering a new language is, let's be honest, way more complicated than just memorizing a new dictionary. See, when you're trying to learn a new language, your brain is doing this incredible juggling act. You're figuring out tricky verb structures, you're trying to grasp all the subtle shades of a word's meaning, and you're trying to understand the role each word plays, like who's doing the action versus who's receiving it. And, on top of all that, your native language is always in the background, trying to butt in and apply its own rules where they just don't belong. So, all of this difficulty leads us to a massive question in cognitive science. How do we actually pull this off? Are our brains working from some kind of pre-installed blueprint, or are we literally building our knowledge of language from scratch? For a long time now, this debate has had two major camps. On one side, you've got the nativist theory, famously pushed by Noam Chomsky. It basically says we're born with a universal grammar already hardwired into our brains. Learning a language is just about activating those rules. But on the other side, there's the usage-based theory. This idea suggests that we learn from the ground up, kind of like little detectives, just by spotting patterns in the thousands of examples we hear and see every single day. Okay, so to really put that usage-based theory to the test, researchers did something brilliant. They built a computational model. You can think of it as a digital student, and they designed it to learn a new language with zero pre-programmed grammar rules. It had to rely only on experience. So how does this digital student actually learn? Well, it's fed thousands and thousands of what are called scene utterance pairs. This is pretty much exactly how a toddler learns. The model gets shown a scene, say a person drinking water, and at the exact same time, it's given the sentence that describes it. Its whole job is to figure out the connection between what's happening and the words being used. Let's walk through its thought process. First, it just observes the scene and the sentence. Then, it pulls out key info about the meaning and the grammar into what's called a data frame. After that, it compares this new frame to all the other ones it's seen before. And finally, it starts grouping similar frames together. And this is how it builds abstract grammatical patterns, or what linguists call constructions. And this is the absolute key right here. Nobody ever tells the model, hey, the verb goes after the subject, or this is a noun. It has to figure all of that out on its own. Basically, by playing the odds, it makes these incredibly smart statistical guesses about the rules of the language based only on the patterns it sees in the data. Okay, and this is where it gets super fascinating. When the researchers started tracking the model's progress, its learning journey looked eerily human, mistakes and all. What they saw was this classic pattern known as the U-shaped learning curve. It's this really counterintuitive thing that happens where a learner's performance actually gets worse for a little while before it gets way, way better. It's not a bug, it's actually a feature of real deep learning. So in stage 1, the model does great. It's hitting about 90% accuracy. It's kind of like a tourist with a phrasebook. It can perfectly repeat sentences it's heard before. It doesn't really understand why the words go in that order yet, but it's a fantastic mimic. But then we hit stage 2, and its accuracy just plummets. So what's going on? Well, the model has started to recognize a pattern, a rule, and it gets so excited that it just applies that rule everywhere. This is called overgeneralization. It's the exact same reason a little kid learns to say, I gooed to the store instead of I went. It's a mistake, for sure, but it's a sign of incredible progress. And then finally, we get to stage 3. After seeing more and more examples, the model starts to learn the exceptions to the rules it discovered. It refines its understanding, and its performance just soars, climbing even higher than it was at the very beginning. It's achieved true mastery. But that's not all. The model also showed another totally human trait, something called L1 interference.
Just like us, when it was trying to make sense of a new language, it leaned really heavily on its first language. And that, of course, led to some very predictable mistakes.
And this example just nails it. In French, the adverb like souvent or often usually comes after the verb. In English, it usually comes before. So the model, when it was first trained on French and then started learning English, would make that classic learner mistake. It would say something like, Adam sees often Eve, applying the rules of its first language directly to its second. So what's the big takeaway here? Why does building this digital student even matter? Well, because it takes that invisible internal process of learning that happens in our brains and makes it something we can actually watch, measure, and understand. Well, this research shows us that messy, mistake-filled journey to fluency, it's not random at all. It's actually a logical, predictable pattern. It's also powerful evidence that our brains are just these incredible pattern-detecting machines, learning from experience, not working from some pre-installed grammar book. And by making this whole process visible, models like this one can help us build smarter, more effective learning tools that actually work with our brains, not against them. And all of this really leaves us with one big question to think about. We tend to think of mistakes as failures, as something to avoid. But if this digital student shows us that making mistakes, overgeneralizing, and then correcting course is the actual path to mastery, well, what does that say about our idea of the perfect way to learn? Maybe it's not so perfect after all. Maybe it's about embracing the messy, beautiful process of getting it wrong, over and over again, until you finally get it right.